If A is symmetric, prove that adjoint of A is also symmetric. Suppose A is a symmetric matrix, then A transpose will be same as A. Then this theorem already we completed. Adjoint of A transpose will be same as transpose of adjoint of A. Now, since A is a symmetric matrix, A transpose will be same as A. Instead of this A transpose, you write A. Then adjoint of A is transpose of adjoint of A. That implies adjoint of A is symmetric because transpose of adjoint A is same as adjoint of A. So adjoint of A is also symmetric. Now we will see a theorem. If A and B are any two non-singular square matrices of order n, adjoint of AB is equal to adjoint of B into adjoint of A. Let us see the proof. A inverse is equal to adjoint of A divided by determinant of A. You are familiar with this relation for A inverse. A inverse is adjoint A divided by determinant of A. If you rearrange this expression, you will get an expression for adjoint of A. Adjoint of A is equal to determinant of A into A inverse. In this expression, you replace A by AB. Wherever A is there, you write AB in this expression. So adjoint of AB is equal to determinant of AB into AB inverse. So adjoint of AB is equal to determinant of A into determinant of B. Here we can use product rule of determinants. Determinant of AB is equal to determinant of A into determinant of B. Here we can use reversal law of inverses. AB inverse is B inverse into A inverse. Here determinant of A is a number, determinant of B is another number. So we can rearrange this. Determinant of B into B inverse into determinant of A into A inverse. This we can rearrange and get like this. Then we can again use this relation. Determinant of A into A inverse is adjoint of A. So this can be written like this. Determinant of B into B inverse can be written as adjoint of B from this relation. Similarly, this also determinant of A into A inverse is adjoint of A. So now we are getting the relation adjoint of AB is equal to adjoint of B into adjoint of A. So this is a theorem. If A and B are any two non-singular square matrices of order n, then adjoint of AB is equal to adjoint of B into adjoint of A. Now we will see a problem. Verify the property A transpose inverse is equal to A inverse transpose with this square matrix. We are given a 2 by 2 square matrix. We have to prove this relation. Here we are taking the transpose first, then taking the inverse. This side we are taking the inverse first, then taking the transpose. We have to prove this, verify this relation. First, let us see the determinant of A. 2 into 7, 14 minus 1 into 9, 9. So 14 minus 9, 5. So determinant of that matrix is 5. So it is a non-singular matrix. So A inverse exists. Then for finding the inverse of the matrix, we can use this formula. A inverse is adjoint A divided by determinant of A. So we have to get the adjoint of this matrix. So the cofactor of this 2 is 7. Cofactor of this 9 is minus 1 with a negative sign, because this 9 is in the first row and second column. 1 plus 2, 3. Odd number means we have to change the sign. Next, cofactor of this 1 is 9 with a negative sign, because this 1 is in the second row and first column, second row. 2 plus 1, 3. Odd number, so it is minus. Then the cofactor of the 7 is 2. Then this, take this 1 by 5 inside. So A, we are getting A inverse. First we found out A inverse. Then take the transpose of this matrix. The first row is written as the first column. Then second row is written as second column. So we are getting the transpose of this matrix. First we found out the inverse of the matrix. Then we took the transpose. Take this 1 by 5 outside. So we are getting A inverse transpose. Next we will see this side. You take the transpose first. First we got this side. A inverse transpose. Now we have to get this side. So you take the transpose of that matrix. A transpose. A transpose is, take the transpose of this matrix. First row is written as the first column. Second row is written as the second column. So we found out first the transpose of that matrix. Then you find the determinant of that matrix, A transpose. That is 14 minus 9. 2 into 7, 14, minus 1 into 9, 9. So it is 5. Now you have to find out the inverse of this matrix. Again you can use this formula. Inverse of a matrix is adjoint A divided by determinant of A. Cofactor of this 2 is 7. Cofactor of this 1 is minus 9. Write the cofactor of this elements as the first column. Because adjoint of a matrix is the transpose of the cofactor matrix. Next, cofactor of this 9 is 1 with a negative sign. Cofactor of this 7 is 2. Then determinant of A transpose is 5. So A transpose inverse is 1 by 5. Then this matrix, adjoint of this matrix. So inverse of a matrix is adjoint of A divided by determinant of A. So we can get the A transpose inverse. You can see that these two are same. These two matrices are same. That means A inverse transpose is same as A transpose inverse. Now we will see another problem. Verify AB inverse is equal to B inverse into A inverse. So this is the universal law of the product. Here finding the inverse after multiplying. Here after finding the inverse we are multiplying. So we are given 2 by 2 matrices. First we have to multiply these two given matrix A into B. So we know how to multiply two matrices. So after multiplying you will get like this. Then AB inverse. You have to get the inverse of this matrix. For that we should know the determinant of the matrix. Determinant of this matrix is 0 into minus 7 is 0, minus 3 into minus 2, minus 6. Then you have to get the adjoint of this matrix. Cofactor of the 0 is minus 7. Cofactor of this 3 is minus 2 with a negative sign. So it is a plus 2. So we can get the adjoint of this matrix. So AB inverse is this matrix. AB inverse. We are getting the AB inverse. Next, inverse of this matrix. You have to get the inverse of this matrix. You know how to find out the inverse of a matrix. Inverse of a matrix is adjoint A divided by determinant of A. So you are getting A inverse. Similarly, you have to get the inverse of this matrix, B inverse. Then we have to find out the product B inverse into A inverse. So you multiply these two matrices. This is a B inverse, 1 by this B inverse. Then A inverse, this is the A inverse, 2 into 3, 6. Then you multiply these two matrices, you will get this. So now we have proved AB inverse is B inverse into A inverse.